Sure. Good afternoon, everyone. Welcome to this session on distributed collaboration. My name's Laura Hay. I'm from the University of Strathclyde, and I have the great pleasure of chairing the session this afternoon. So we have 5 really interesting talks from some really great presenters. So just to introduce you to who we have in this session, first up, we have Miguel Pacheco, presenting his paper, Challenges and Opportunities in Remote Prototyping, a Case Study During COVID-19. Up next, we have Nikola Horvat, presenting Design Reviews in Immersive and Non-Immersive Collaborative Virtual Environments, Comparing Verbal Communication Structures. And many congratulations to you, Nikola, and your team for being receiving a Reviewer's Favourite Award for your paper. Very well done.
Thank you.
Next, we have Elies Dekoninck, presenting her paper, Testing Typical Challenges Affecting Idea Sharing in Distributed Design Teams Today. And that will be followed by Iseline Bisson, presenting Proposal of a Conceptual Framework for Collaborative Design of Immersive Professional Training, Application to the Textile Industry. And last, but definitely not least, we have Katerina Dürr, presenting Enabling Distributed Teams, a Process Model for Early and Continuous Model Validation. So I'm really looking forward to your talks. It sounds like some really interesting work. Obviously, these presenters are also presenting on behalf of their co-authors as well, so you can find the full list of co-authors for each paper in the conference schedule and in the abstract book as well. So the way we're going to run today is the authors have pre-recorded their presentations for us, so we'll kick things off by watching the video of the presentations, and then we will have a discussion afterwards with all the presenters. While we're watching the video, could you please post your questions for the presenters in the chat? It's really helpful if you can also indicate who the question is for as well. And then once we finish the video, I'll use the questions in the chat as a starting point for the discussion. And obviously, please continue to add questions throughout the session as you think of them as well. And obviously, that goes for you as well, presenters. If you have questions for other people in the session, please feel free to add those. Okay, so the only other thing is just when we're watching the video, could you presenters please make sure you're muted just so we don't get any feedback, which you all appear to be, which is great. And I am going to hand over to Marko to play the video, please.
Hi, everybody. My name is Miguel Pacheco, and I'm a PhD candidate from the Laboratory of Product Development and Lightweight Design from the Technical University of Munich. This paper was a collaboration between the Imperial College and TOM, and I'm going to present you briefly our paper, Challenges and Opportunities in Remote Prototyping, a Case Study During COVID-19. So, when we try to develop new products, we build a lot of prototypes and go through a design process. It is usually an iterative approach by making concepts tangible as we want to think through making. The prototypes are built to test hypotheses and to reduce uncertainty as you want to learn through failure. And in addition, we test with customers early on as we want to get real feedback very quickly. And here you see a collection of different prototypes built during design projects. And normally we do a lot of studio work. We do a lot of teamwork. We have access to workshops, to the tools. We build a lot of physical and digital deliveries. But what happens if we are in the situation of home-based work, remote team working, no access to workshops and makerspaces, and fully digital deliveries? So that's what we ask ourselves and want to figure out what facilitates remote design projects. This research was conducted within the Tangibility Project. It was a 6-month design collaboration project between the institutions, and we had 14 students in 4 teams. And we tried to address the following questions. First, what are the challenges and opportunities with prototyping over a project lifetime during COVID-19 and in remote design engineering? This was addressed through interviews and surveys. And second, can the double diamond approach combined with state-of-the-art tools such as VR technologies help overcome these challenges? This was addressed through the methodology adoption and also the documentation of their process. The teams received a design brief to design an innovative input device, such as a haptic VR glove or a controller or a new user interface. In addition, we gave them a project timeline and they received a specific design sprint week that they should attend. In addition, the teams utilized the double diamond approach, and for the sake of simplicity, we tried to rationalize the double diamond approach into 3 project phases: the problem exploration, the prototyping phase, and the prototype delivery phase. And in the figure below, you can see the pictures of the outcomes of the team throughout the process. In the double diamond, they started with a lot of digital prototypes and ended up with real hardware prototypes in the end. In this figure, now you can see the results from our survey that we conducted with the teams on the challenges and opportunities. The teams were clearly motivated to participate in an international collaboration project despite the limitations of the pandemic. And the team composition involving the right people and increased individual creativity were important to overcome these challenges. And one of the biggest challenges the teams faced were physical prototyping development, the generation of user requirements, and also testing, as they had limited access to manufacturing capabilities and there was a reduced supply chain. Testing and user feedback surveys are normally done in person, but had to be shifted virtually, which led to a decrease in quality of the feedback that the participants got. And tools like Microsoft Teams, Zoom, Miro, or Gravity Sketch reduced the pain points of communication and collaboration. In another survey, we tried to figure out what tools and techniques the teams had to use in each of the project phases. In addition, the teams were asked to rate the importance of the tools for the respective project phases. In these graphs, the respective teams are color-coded and the tools and techniques are highlighted through icon shapes. And we can see that the teams differed in the use of prototype method and tools depending on the phase that they were in. And however, we see that there was a consistent use of communication tools and collaboration tools during the entire process, but it can be noted that collaboration tools were rated less important towards the end, while also being used less frequently. The use of 3D CAD was at its highest during the prototyping phase, the second one, as it provided a platform to collaborate in real time to realize ideas and prototypes in 3D. But this was limited to low fidelity prototypes, and as they reached the stage of high fidelity prototypes, they had to switch to more traditional CAD applications and also physical prototyping. So to sum up the findings, we investigated the usage of different tools and techniques used in remote design engineering projects during COVID-19 restrictions. And communication was expected to be one of the biggest pain points, but did not out to turn out true. Instead, the teams had problems with realizing the physical prototypes and feature integration because of limited access to tools, missing infrastructure, supplier problems, and mostly isolated development. This hindered the rapid prototyping and also the quick communication between the team. But the remote work also gave opportunities. For example, 3D CAD tools allowed the teams to work together in real time on 3D models. And the results showed that the different tools and techniques successfully supported the remote development projects. However, also problems remain which need to be solved. For example, the abundance of different tools without a proper integration. There was just too many of them. And a major area for improvement, which we see, could be in building high fidelity digital prototypes that can be tested in virtual environments. This, of course, would require more haptic feedback, as we need to increase the physical interaction with products and experiences in such remote scenarios. So that's it from my side. I'm really looking forward to your questions and for the great discussion in the session. Feel free to check out our paper and reach out to us. Thank you very much. Bye.
Hi, I'm Nikola Horvat, PhD student from University of Zagreb, working on understanding the potential of virtual reality for design teams. And today, on behalf of my co-authors, I will present our paper, Design Reviews in Immersive and Non-Immersive Collaborative Virtual Environments. In short, we compared who communicated when in team review sessions conducted with virtual reality or CAD. But let me start from the beginning. You probably understand the importance of reviews. For example, if you look at any work you have done, being that writing a paper or making a presentation or making a design, you probably appreciate the work done during reviews. And while in stage gate model of product development, these reviews are only in between phases, they are actually often conducted within phases. For instance, reviewing a design results in number of required changes before going into next phase. Hence, in product development, there is a lot of reviews, either formal or informal. And these reviews are thus one of the core design activities where many important decisions are made. And with the many unfortunate circumstances last years, there is increasing demand to conduct these reviews virtually. And there is a lot of opportunity in that direction, with various technology which can affect design reviews. The common variable being observed is the immersion level, basically the extent to which technology affects users' sensory system. For example, CAD on screen is low immersion, as you only simulate part of our visual system, while VR with head-mounted display is high immersion, as you also support additional depth cues. Considering immersion, previous research did not really reach a conclusion regarding its effect on outcomes, as some researchers got improved and some worsened reviews. Moreover, there is lack of research regarding the team-based reviews, especially those where each user can manipulate their view. Hence, we decided to investigate mediators that might potentially affect outcomes. One such mediator is verbal communication structure, a concept which shows who is talking when and what are the common communication sequences. This concept can show patterns in subtle information and identify session leaders and can provide useful information about review sessions. Basically, we conducted an experiment with 10 reviews. Each review lasted for 60 minutes and included designs made by a design team. The review team had a design representative and 2 reviewers that worked in industry. The designs reviewed include wheelchair, weightlifting machine, baby stroller, tricycle, and office chair. Each product was designed by 2 teams, thus having 5 design pairs. One of them is reviewed in CAD and another in VR. For the CAD environment, we used Onshape, which is presented at Google Docs for CAD. What's important feature of Onshape is that it enables independent viewing of the design, but also following other people that are currently on the document. Here you could see the interaction between independent view, and you could also see how others could also sync their viewpoint. For the immersive environment, review members were again in separate physical rooms, while they met in the virtual room. Basically, they could comment on the design, mark the particular part, take screenshot, make section cuts, and so on. And from the results of the experiments, we could see several patterns related to the verbal communication structure. First, we found that the designer talked the most in both environments. What's also quite interesting is that the relative proportion of team members did not change between the 2 environments, as the means for non-immersive and immersive are quite close for each role. Furthermore, we analyzed each possible conversation sequence, and from the results, we could see one interesting observation, being that there is significantly more sequences amongst reviewers in immersive than in non-immersive CVEs. In other words, after a reviewer is talking, the probability that another reviewer will start talking is higher in immersive than in non-immersive environment. And indeed, we conducted a paired t-test for the results, and the results were significant, and the effect sizes were large. Overall, The results show that there are dyadic sequences between a designer and one reviewer. These findings suggest that designers have an important role in design reviews, probably related to their role found in previous work, being explaining the work, but also persuading others into their solution. Another finding is that there are more sequences between reviews in immersive CV, suggesting that reviewers collaborated more in this environment. If more collaboration in immersive environment is the case, they might partially explain the lower number of identified issues in this environment, work which we published elsewhere. We are still exploring why this might be the case, but one explanation is that there might be higher awareness of member section in immersive environment, since there you could always see the avatar and what they are doing or looking at. With these findings, several implications for researchers and practitioners exist. For example, researchers have information that technology affects process variables in team-based design review, and that they can use different environments to understand some design review aspects. This may really help to move the field forward, as anyone studying reviews knows that there is not much work about them. Practitioners could use this finding to help them decide which tool to use. If they want to facilitate verbal communication with a designer, they should use non-immersive environment. However, we believe it's not that simple, and many other work is necessary. As our first step, we are already working on content-dependent analysis to shed more light onto the subteams formation and to see not if, but for what immersive environment is better than non-immersive and vice versa. Finally, we'll also work to see the generalization of our results. And that's it. Thank you very much for your attention. I'm open for any further questions now or via email, LinkedIn, or ResearchGate. Thanks.
Okay, if we could just have a brief pause in the video there. So, Nikola, you're going to have to use your imagination here, because at this point in the proceedings, I would usually be handing you a certificate for the Reviewer's Favourite Award you received and your co-authors received on your paper. So once again, very many congratulations to you.
Thank you. Thank you.
Okay.
Hi, and welcome to my short presentation of my Design 2022 paper called Testing Typical Challenges Affecting Idea Sharing in Distributed Design Teams Today. So my name is Elies Dekoninck. I'm from the University of Bath, and together with Charlotte Brenninkmeijer, I created this paper. We were working on Charlotte's master's dissertation at the time. Our aim was to test previously identified challenges of idea sharing in today's distributed teams, as we obviously had an opportunity to do so as part of the COVID pandemic, like many other people. Our research question is, to what extent are the challenges affecting idea sharing in distributed design teams found in the literature still evident in today's modern context? So, what we define as idea sharing is any group activity with the purpose of progressing the design process. So the first thing we did was search the literature on the challenges that affect virtual design teams compared to face-to-face teams. And those really fell under the four themes that are most important: building trust, sharing information, use of technology, leadership, and organization. So, for example, by studying the literature on technology, we found that communication technologies do combat distributed design team challenges. However, they only work if individuals learn to adapt to those communication patterns needed and the expectations of other team members. So now a little bit on our methods and data collection. We had 3 design teams studying engineering design. These were in teams of 6 or 7, and they were working on a 4-month full-time project for industry, and they were asked to self-record during approximately 8-week period where they should record any meetings where they were idea sharing. It yielded 8 useful recordings that we were able to analyze. Our unit of analysis is an idea sharing instance, which starts when the team moves on to a new idea and ends when they finish talking about that idea. So they're basically big chunks of the protocol. And in total, we ended up with 44 idea sharing instances to assess. We scored the effectiveness of each idea sharing instances and averaged them for each session in order to relate those session scores to the challenges identified in the literature. So our session recordings were transcribed, split into idea sharing units, and then coded using the number of questions asked, ideas generated, comments made, and topics debated. And you can see examples of quotes from the transcript that we would have coded as such.
Sorry, I was wondering if you could have like almost like a detachable tablet. So say if you do go for an enclosure, can you have a tablet?
That was an example of how we go from the recording all the way through to the coding. We conducted intercoder reliability tests that gave us 85% agreement using instructions for how to code these variables. So we chose a number of session characteristics to compare with the average session scores, as you can see in these examples on this slide. So we were looking at the structure and time limits that teams used, and we took extensive notes, for example, on how sessions were structured and how strict they were at sticking to those structures and whether any time limits were imposed. We did that also for leadership, social interaction, and all the tools used. And this created our data set in relation to the scores we had given. We had a good variation in the session scores, from the worst session scoring 3.67 to the best session scoring 8. This allowed us to draw some conclusions on the challenges that we'd found in the literature. We draw conclusions on structure and time limits, and also on leadership roles and group dynamics. For example, on structure and time limits, we found that more structured sessions had higher scores in the sessions, and that was in line with the literature. So having clear rules and formal guidelines for the sessions were great, but sessions with no time limits imposed also had the highest scores, and no teams actually struggled to create their organizational structures. We also had some results on informal speaking and observations on the effects of the tools used on the session scores. We found that all conferencing platforms and live collaboration tools could be adapted to the session's needs. In general, we found that file and screen sharing, preparation in advance, and collaboratively making changes in real time seem to have overcome typical challenges affecting idea sharing in distributed design teams in the past. We also had some findings on informal speaking, relating those to the overall session scores. Now, a few words about conclusions, limitations, and further work. The 4 challenges that we found in the literature on distributed design teams were not really found to be challenges in this particular study. Practices within modern distributed teams have changed. Training and exposure to designing virtually and the use of appropriate collaborative design tools can now overcome many of these challenges. The limitations of our studies were that these teams already had the advantage of having worked together for 10 months during the pandemic. That gave them a good experience and some exposure. They were also highly motivated to work together as there was no in-person working at the time. We did not make direct comparisons with these teams to face-to-face teams, nor did we make comparisons with professional teams. And the other limitation is that our participants controlled their recordings. That was to ensure that these recordings would be as naturalistic as possible. However, we may have missed some recordings that were important. In further work, we would of course want to address these limitations in our methods, and we would like to add a time efficiency score for the actual unit scoring. Thank you very much. Look forward to your questions.
Hello everyone. First of all, I wanted to thank the people present for this presentation. My name is Isaline Bisson. I am in my second year of my thesis, and I am going to present to you our work on a conceptual framework for collaborative design of immersive professional training and its application to the textile industry. This work was carried out by the Elies Laboratory and the Stobli Company. First, I will describe the context and the problematic of this work. Then I will briefly present a state of the art and present our framework and its application for an industrial project. Today, in the context of industry, new production technologies use constantly evolving industrial resources and processes. Faced with such development, manufacturers must think about training methods that will allow their employees to improve their skills and adapt to new modes of production. Some companies choose to take advantage of immersive technology as virtual reality or augmented reality. In the field of training, it has been accepted for many years that IT offers real benefits. Despite the maturity of this technology and its visible industrial application, there are still obstacles to its full integration in the industry. The biggest issues related to IT application are the lack of usability, utility, and good user experience. For example, the company Stobli tested application already existing on the market, but the experience was not conclusive because the applications were not adapted to the constraints of the company and their users. This is why the company has decided to design its own application. There are improvements that can be made as collaborative design with different experts as VR designer, ergonomist, and didactician. Also, user-centered design and adaptation to industrial constraints. Our objectives are to propose a conceptual framework and apply this model to a project in the textile industry. In the literature, we search for methodologies for designing applications using immersive technologies. These works show us that many improvements have been made to existing methods in past years, but they have limitations. Few of the works clearly specify how and when to collaborate. Few propose to work in parallel time for less sequential processes and potentially reduce project time. To finish, they are not completely adapted to the industrial constraints. This is why, from this synthesis, we propose a conceptual framework unifying previous methods, clarifying the role of each profession, and highlighting the collaboration phases between professionals. Our framework is composed of the main stages of a design process, starting from analysis of need to use and feedback. In this work, we will only detail the first two steps. The first step, analyze the need. It's divided into two phases. A first one, cooperative, where the project manager and the ergonomist will come to analyze the needs of the sponsors and the users. Then comes a second, more collaborative, with the integration of the didactician and the VR designer to create a common representation of the future artifacts based on the needs analyzed upstream. The second step, designing the conceptual artifact, is also carried out in the two phases, cooperative, then collaborative. First, the experts will analyze the work and the training according to their point of view. Then, during the collaborative phase, they will create a common representation of the training and construct its contents. Now, let me introduce our industrial project. The objective was to apply the conceptual framework to improve the current training of the Dobby assembly station. Dobby is a part of the weaving machine. The Dobby assembly station was chosen because there are several limitations to the current training. First, it's carried out in companionship with an expert operator on the workstation. The training period is long, and the request for hiring and therefore training is critical for the textile sector. The application of the framework allowed to obtain an application based on virtual reality to complete the companionship part of the training. That is to say, the learner will have several virtual reality exercises during his training. This application will simulate part of the assembly, providing them more exposure to the job and encounter hazards which are infrequent during the companionship. Thanks to this project, we apply for the first time this conceptual framework. Also, we are able to highlight certain points of improvement. One of the first limitations is that within a company, it's not always possible to have access to specific professionals. In our case, the didactician was represented by the project manager. It's therefore necessary to provide guidelines to non-experts. Also, the analysis of the activity made it possible to observe only trainers, but for a complete study, it's necessary to analyze the learner activity. To finish, to improve the convergence phases, we can use also tools to encourage the creativity of users and project them into their future solution thanks to intermediary objects known for their characteristics of representation. To conclude this presentation, our work carried a state-of-the-art and collaborative and user-centered design of immersive professional training. And inspired by existing work, we have also proposed a conceptual framework and we apply it through an industrial project for the company Dobby. This allows us to discuss the evolution of this framework. The perspectives for this work are to analyze the virtual reality tool from a usage and pedagogical point of view and to adapt the framework for new projects. Thank you for your attention and have a nice day.
Hello everyone, my name is Katharina Dürr from KIT in Karlsruhe and I welcome you to the presentation of Enabling Distributed Teams, a process model for early and continuous method validation. In response to emergent changes caused by the ever-increasing complexity of advanced systems, represented through, for example, new product services, interactive socio-technical systems, or interactive and autonomous systems, product development teams need to aim for interdisciplinary collaboration. But these domain competencies are often not located in one place, and that is why companies are increasingly relying on distributed product development teams. Can you see me now? Hello, can you hear me? I'm sure all of us know many situations where a meeting starts out just like this. And these problems concern only a normal meeting. With the introduction of the distributed way of working, product development is confronted with new problems, such as the significantly more difficult coordination of work. Consequently, losses in effectiveness and efficiency are imminent. We developed a method that enables distributed development teams to continuously improve their collaboration based on their actual development situation. The method is called the EDIT method, enabling distributed teams. The edit method is based on 4 phases: potential analysis, measure definition, measure implementation, and measure evaluation. The unique feature of the edit method as a method to support continuous improvement is that it incorporates the characteristic of distributed product development. This work aims to develop and apply a process model for the early and incremental validation of the edit method in a field study regarding its applicability and its contribution to success, to support the applicability of the method in practice right from the start. The following research questions were derived to structure the research project. First, what are the requirements for early and incremental validation of the edit method in industrial development practice? How can the edit method be validated in a field study regarding its applicability and its contribution to success? And third, what contribution can the use of the developed process model provide to validate the edit method in an agile development practice using the example of a machine tool factorer? To answer the research questions, we use the approach of the DRM according to Plessing and Chakrabarty. First, the requirements for early and incremental validation are determined in an initial descriptive study based on a systematic literature review. Subsequently, a process model is developed in a prescriptive study. Finally, the contribution of the developed process model is evaluated in a second descriptive study at Trumpf. In this, an agile distributed development team of 11 people used the edit method and was accompanied by a researcher that applied the developed process model. Let's have a look at the results of the DS1. In total, 7 requirements have been identified that need to be addressed in a process model that supports the early and incremental validation of the edit method in the field. A process model, therefore, needs to support the evaluation of the applicability of the edit method, the evaluation of the contribution to success, the examination of the suitability of the underlying challenges in the company, the enabling of statements regarding the internal and external validity, the reliability, as well as the objectivity of the results, the guarantee of comparability of conducted studies, the iterative application possibility of the process model, and the enabling of a suitable selection of measurable variables to validate the success of the method. Answering the second research question, the requirements were addressed by developing a process model that supports early and incremental validation of the edit method in the field. A framework consisting of 4 categories was developed. The 4 categories are the validation through application, the validation through evaluation of the contribution to success, and the validation through matching of requirements. And lastly, we have the recommendations for further development of the edit method that can be derived from the insights of all 3 validation categories. Let's just have a quick look how the category 1, the validation through application, supports the examination of the suitability of the challenges and the evaluation of the applicability. In the first step, the potential analysis, in our example, the team identified the activity of managing projects as their critical activity due to efficiency and effectiveness losses in a moderated workshop. In particular, the daily was selected as an activity to focus on. In the potential analysis step, the field of action, team internal organizational structures, and interpersonal communication were determined as the most potential fields of action for improving distributed collaboration. In the more in-depth analysis of the potential for improvement, the dailies, for example, were consistently described as anonymous and tough, resulting in a bad mood in the team. As one of the first measures, it was decided that in future, all videos should be activated during the daily meetings and that a daily personal question is being asked. In step 3, the measure is implemented by the team, and in the last step, the measure evaluation, the evaluation of the implemented measures is performed. The requirements, evaluation of the contribution to success, and the enabling of a suitable selection of measurable variables is focused in category 2. In our case, for example, the moment of laughter and the amount of time spent in silence is defined as a measurable variable. We measured a significant reduction in the amount of time spent in silence from around 2 minutes to 3 seconds, and in addition, an increase in loud laughter from an average from 1 to 9 in a 15 minutes daily. And as we all know, a good laugh improves our team climate. Coming to the conclusion, several requirements for early and incremental validation of the edit method in the field were identified and addressed in a process model. In a case study at RUMF, it was confirmed that all 7 requirements were largely met. So what's next? We will work on the use of the procedure model in coming validation studies in the field, where we also will focus on the further development of the process model as well as the edit method. And lastly, the process model will be transferred for other development methods. Thank you very much for your attention. We are really looking forward to discuss some ideas with you.
Okay, thank you so much to all of our presenters. Great job. Some really interesting work and ideas in all of your presentations. And we had lots of questions popping up in the chat as well, which is great. So I think we will just dive straight into the discussion. And I think what we will do is go around each presenter first and ask questions individually. And then if we have time at the end, we can maybe have a more general cross-cutting discussion at the end as well. So I've been frantically noting down the questions that were coming up in the chat, and I will start with those. And if we run out of questions from the chat, then I'll maybe invite anyone in the audience to turn on their camera and ask a question directly. So starting with you, Miguel, we had a few questions. The first one that popped up was from Khadija. I'm really sorry if I'm butchering the pronunciation of your name. But the question was quite straightforward, and it was, were there any of the findings from your work that you found surprising, or what was the most surprising?
Yeah, good question. So we started with the whole topic as we thought, okay, communication might be the worst which can happen in such projects, because also we are the first ones doing such research. This has been done before, but as the development of new tools progressed during COVID-19 in the beginning, we thought, okay, let's try it out and see if this is the case. And what we figured out was basically that those real-time applications really helped in the beginning, for example, in brainstorming activities where you normally sit together, you try to come up with new solutions, or you try to find problems that are worth to solve. And for example, Miro, but also VR, CAD really helped to brainstorm, because they just could draw things and explain it while drawing. And this kind of had the feeling of being in the same room. So this was definitely a nice insight that we got that we didn't expect.
Okay. There were a couple of other questions. I think you kind of touched on maybe the answer to one of them there. These were from Nikola and Ross. I'm going to kind of combine them into one question. So talking about the tools, the prototyping tools that you were using in this context, Nikola was asking about whether you have any suggestions for how those tools should be used. But Ross was also asking, sometimes there's a discussion around whether it's better to have a kind of all-in-one tool that does everything, or whether it's better to have a range of tools that are integrated together. So I don't know if you have some comments around that.
Yeah, so to answer the first thing, so in my opinion, it's complementary. So you have different methods, you have different tools, and I see it as a puzzle, and you have a lot of pieces, and you try to combine all of those, and they all make the process. And to answer the second question, basically, I don't see the point in developing the one-and-all solution, because this would require a lot of different backgrounds to do so. And I think it should rather be something that makes the interfaces easier. So something that lets interact the different applications or methods. This should be the way to go, and not to come up with a one-and-all solution. Because if you look at software development, that was what they tried to do. For example, Facebook is a good example. They tried to do one app that basically had everything included, and now they basically are not going to this direction anymore because it didn't work, and they try to divide the different functionalities. So I think an integration would be very helpful, but not the one-and-all solution.
Okay, sure. One final question from Katerina, which was, which phase of the development process did you find was least negatively affected? in terms of prototyping from this remote working?
Surprisingly, I would say the first phase, so the problem exploration, because we started with the assumption that the whole brainstorming activities would be very difficult to do, because we also teach our students to build prototypes early on, to think about what could be the problems, to put themselves in the shoes of the users and so on. And they really managed to use the tools that they had at the disposal to figure out problems which are worth to solve. They used Zoom meetings instead of going to the users, and they came up with ways on how to do those observations via Zoom, and this was definitely very nice to see.
Yeah, I think that mirrors my own experience from teaching during the pandemic, just how resourceful the students were at coming up with solutions to some of these issues. Actually, Elies, I noticed you had a question as well. I don't know if you want to ask it directly.
Yeah, so my question was, when because you surveyed your participants, right, on their experiences, that's right, isn't it?
Yes, we did.
So were they comparing, the questions were a bit comparative. Did you make it clear whether they were comparing to what they expected or what their past experiences were?
So the survey was done after the project, and therefore they should compare it according to their own project, and therefore it has a comparative character, yes.
But I mean, do you think that they, when they answer the question like how good was such and such, when you say like how good is such and such, is it in relation to their past experience or in relation to what they were expecting at the beginning of the project?
That's a good question. I think so. How we tried to frame it was that they should consider it from their past experiences. But of course, we can't. We interviewed them afterwards as well, but it's very difficult to draw a line between those two. That they didn't consider also their, basically expectations on the tools, but we didn't go into detail with that.
Okay, sorry. Thanks.
You.
Okay, thanks, Miguel. So I don't think I saw any more questions at the moment for Miguel, so I think we'll move on to Nikola, the second presenter. So Nikola, I'll start with a question from Ross, which was also something that I was wondering as well. So Ross was asking kind of about the learning curve associated with VR and the fact that very often in an educational setting and these kinds of tasks, it's important that the students are able to fully use all of the features of the tool in order to be able to actually do the task successfully. How long did it take before the students were able to learn everything about this VR system and really focus entirely on the task? And do you think there were any effects associated with them kind of becoming familiar with the system that they were using?
Yeah, thanks for the questions, Ross and Laura. So, yeah, basically, I mean, first, just to answer, we don't think that there are any influences in the results due to their experience in VR and how long did they went there. So they had a training of like 30 minutes, 45 minutes, which, I mean, we base that on previous experience of us, but also of other researchers, because we use VR for reviewing products. So, and like if you give people like just to review something, they use just few tools. It's like they use a section cut maybe, and they can use paint and they use screenshot. So it's like it becomes like it's not like creating models. To create models would take probably like one course just to master that in order to be able to compare. And that's one of the reasons why we focus now when VR is like still new and buzzword to focus on those reviews where we can just quickly learn people and just test some things with them. But like we find it like 30 minutes, 45 minutes for these 4 or 5 tools just to kill the wow effect and just to learn those few tools. Yeah.
Sure. Okay. Another question kind of, I guess, on the features of the tools. So Gaetano asked, it seems from what you presented that you only focused on verbal interaction and you didn't look at any other kinds of interaction in the virtual world. Is that correct, first of all? And if so, was that on purpose? And do you think that opening up to include other types of interaction might change the results?
Yeah, that's correct. I think that this will not change the results that much. The reason why we studied only verbal communication, we wanted to see, like, VR, it's like it affects like different social cues, and because you see the avatars are moving around, and there are also spatial cues. You see like you have more depth cues and so on simulated. So, and most of the people in the area, probably Dr. Cascini knows that, it's like focusing on the outcomes, just, okay, the number of errors found and so on. And we wanted to, similar to Dr. Giro, which he posted a paper, just to focus on some mediator variable, just to see, does the behavior change? Because we think that behavior has to change. And this is our like first testing for just, it was like, just let's do something quickly, to be honest, just to see if we can do. And we have our student who now also tried to do it automatically, just to see what we can get from these verbal communication structures. Because I now coded those videos with content, and it took me the 1 month of pure coding. I wanted to kill myself, to be honest. And this kind of analysis took like maybe once. Now we have the code. I think that Marko, he's a helper. He works on that. Mm-hmm. And I think now it takes like 2-3 hours just to gather the results. And we don't say it's like something. It's we just say it can help us some sort of preliminary analysis. But of course, like all other cues, we take them into account in the content-dependent analysis, which I do by protocol analysis. Yeah, sure. I hope that answers Dr. Cascini's question.
I'm sure it does. And if he has further questions, maybe you could follow up in the chat, Gaetano. Sounds like possibly there's a bigger discussion to be had there as well. Elies, you had a question as well.
Yeah, it's a bit similar. So I was wondering if you had actually looked at the content of the reviewer to reviewer, because you highlight the reviewer to reviewer as being statistically significantly different from the other interactions. And so whether you'd looked at the content of those phrases, because my worry would be slightly that they weren't actually reviewing, that there were a lot of phrases that weren't directly associated with reviewing, but maybe they were associated with, oh, come and have a look over here. Kind of, they were affected by the VR environment rather than actually associated with the product review. Was there anything like that?
Yeah, and now I'll just do a bit of cheating, because as I said, I watched the videos in detail, and now I have like some qualitative analysis of that. And it's like, yeah, we of course did not know that while we were conducting this.
When you wrote this paper, you wrote the paper before.
Yeah, before this content analysis.
Before you did the real content analysis. Okay, yes. So you might even change your results now.
Yeah, but the results actually did not change much. Basically, this is what I can say. And the results actually, I mean, the people are just trying to work more together in VR. This is like some initial finding that we can share to now. And yeah, and it's like, of course, we are now removing those phrases. Okay, can you do see me, and do you know, and like those some sort of, let's say, meeting management exchanges where we remove them from analysis just to, and we'll do another like a round of results with with those exchanges excluded. Yeah.
Okay, thanks, Nikola. I think just in the interest of making sure we get around all the presenters, we'll move on to Elies. So Elies, Ross had, I guess, a kind of general question for you. He said that now we're kind of moving out of the pandemic. Do you think that students will have a preference for in-person or online interaction? And what do you think about the potential for hybrid working in the future, where you have situations where some students can be there in person and some can't?
Yeah, I think it's really difficult to say. I realize that we're still, I only recently realized that we're currently in at least a year's worth of COVID hangover, whilst we all gradually kind of reacclimatize eventually to what will become the right way of working. So I think there's a big sort of lag of several months whilst people sort of gradually drag themselves out of their bedroom and come back to face, and then there's a big time lag on the kind of working out what the benefits are to your productivity in coming back together. So nothing is normal yet. So I haven't drawn my I'm not sure where we're going to end up, and I think it's going to be at least another year before I'd want to actually comment on that. What was interested in the creativity workshop on Monday in the conference was that there were some very experienced creativity facilitators running the session, and they say that I think one of the speakers today was also saying this, at the early stages. In fact, Miguel, I think it's Miguel saying that the early stages are very well facilitated by some of these collaboration tools. The creative stages, in particular, the getting things down is very well facilitated by these online tools. But one of the things that doesn't work very well is just kind of helping each other by, when you're in the space, there's a very subtle way that humans can help each other, and that is really missing in the virtual. So you can help someone without embarrassing them or calling them out in all kinds of different ways that you can kind of do physically, and I found that really interesting on Monday, and I think that has an effect on teaching and students in the environment. But at the moment, half the staff are still in their COVID hangover, and half the students are still in their COVID hangover. So we're definitely not. I haven't worked out what's going to be normal in a few years' time.
Yeah, I think you articulated really well there, the sense sometimes of, something is missing in this online world, but you can't quite verbalize what it is. And what the example you gave there about being able to help people, I very much identify with that from online teaching. So yeah, and I'm sure we can all identify with the COVID hangover as well, for sure. There was another question from Khadija, who asked if you had considered in your work the effect or possible effect of certain characteristics of the team members. So, for example, the different capabilities of students, whether the students, were they put into teams randomly, or were they picking teams based on who they were friends with? So that kind of interpersonal side of things, academic performance. I don't know if you have comment.
Yeah, I can answer that one really quickly. So they are put into teams based on by other people. So it's not by choice or friendships or anything like that. So all the teams were in the same situation. They were mixed by their abilities and backgrounds and so on. And then the other thing is that what is good about our data set is that because we gave session scores rather than team scores, all teams had good and bad that there wasn't an effect from the different one team being particularly good or particularly something else. It was session, there were session scores. And so there were good sessions, and some teams had very good sessions later on in the project, and some teams had very good sessions early on in the project. And the fact that they were recording themselves also meant that they were only really targeting the sessions to record where they were being productive. So that worked quite well. It saved us a lot of time by them choosing things. So we do think we have a sort of robust and neutral data set across all the teams.
Okay, great. I don't think there were any other questions for you right now, other than Katerina made a comment about your work. She's very interested in it, I think, and was finding it difficult to find literature to cite in this area. Is that right, Katerina? So she's looking forward to finding
Yeah,
more.
I mean, it's really, there are going to be hundreds of papers now coming out because everyone's had the opportunity to look at this. But again, it is a strange and unique situation. So even taking the literature that's going to come out of all the studies like this right now, really, I'm not sure it's fair to compare it with the literature for all the other literature like you found and we found, which is so old. So interesting times.
Indeed. Okay, thanks, Elies. Iselin, we had a couple of questions for you in the chat. So Ross made some very positive comments about your work, so it was a great solution. He asked if you had any challenges securing buy-in from companies. This is quite a big issue with Industry 4.0 adoption generally. Oh, you're muted, Iselin.
Sorry.
Okay.
Yes, of course, it was a big challenge to convince the company. It was a lot of presentation to present the technology, a lot of exchanges with different department services in the company to analyze their needs and to offer them the technology. You have to show them what the gain is for them to order the technology, and the gain must also exceed the cost of the project. But if you can prove the utility and that the tool is easy to use for the user, I think the hard part is done. And now it's easier to convince them with a concrete example adapted to our activity.
Sure. Okay. Another question from Nikola, which was about the implementation of VR for training in your work, and around how much time was needed to do this. So when you're talking about requirement solicitation, the development, the actual practical implementation, what is the timescale like for that?
For us, we took about 6 months to develop this solution, including the purchase of the technologies, but that is too short. We have started using the application with the new employees, and there are corrections to be made to improve the use. So we have to spend a few months to analyze user feedback and improve our application.
Okay. I actually had a question for you as well, which is kind of about how you see this work going forward, and who would actually be applying your framework in practice. Is it something that's intended to be handed over to someone else to apply, or how do you see that working in future?
Sorry, I'm not sure to understand the question.
So who's the intended user of the framework? So you're developing a framework to help people kind of design and implement these training solutions. is it intended that it would be done in-house within the company, or is it a consultancy type thing? How do you see your work being applied in future?
The aim is to use this framework for not for our company, but for other companies too.
Yeah. Okay. Thank you. Okay. There were some positive comments in the chat, Elena, about your solution, so you might want to follow up with those and have a chat with those people later as well. So lastly, Katharina, I have a question for you from Ross, which I'm going to read from the chat. Sorry for the difficult question, is how he opens it. So in your evaluation, you mentioned the success of the project, and Ross is asking, did you define what success is for collaborative projects, and what is the definition?
Yeah, thank you very much for this question. So this question is actually the key point why I'm investigating on the topic in this detail, because it's really a problem when measuring improvement processes for especially in collaboration processes, because I think the most earliest, if you really can say if a project is successful or not, is after releasing the product that is developed. In my case, that was the earliest that could have been in 5 years. So that was definitely no option in that. So what we did is try to focus on measurable success criteria that were known from previous project or experiences from the development team, or also from literature, that has a positive impact on success of a project. For example, like I said, so we had in the presentation the good team climate, where because of that we measured the loud laughter in the daily meetings, where some people say, why are you doing that? But it really had a big improvement process going on there. And for another example was that we measured the time that they took to complete a task compared to previous projects, where we definitely had a lot of references of time that they needed to complete a task. So that also was another way of measuring the success. So yeah, I definitely know about the problems about that, and we try to do it in this way.
Sure. Okay. I had a question for you as well, actually. So you mentioned towards the end of your video that one of the kind of avenues for future work, you were looking to transfer your process model to other development methods. I just wondered if you could talk a bit more about what your intentions are there.
So, for example, we thought that the problem that I wanted to tackle with this is the problem with measuring the improvement of something if you use a development method. And another, I think, a kind of topic related area is the things where you say you will improve not the collaboration, but the knowledge management or something like that. You always have the same problem with that. And so that's maybe a topic where we want to use the process model, where we say, okay, you need to focus on the success that you have, the application of the method. And then lastly is every requirement that was meant to be fulfilled by the method applicable. So yeah, that's, for example, one thing that we want to investigate.
Great. Okay, thank you very much. Okay, so we have a few minutes left. If anyone has any final questions they would like to ask any of our presenters, please post them in the chat just now. Elies, I just picked up you had a question for presenter 4, if you want to ask, which was easily.
Yeah, I just wondered, because you were learning from this case study and you had your framework, which I think you drew out in IDFO, is that right? The method you used, IDFO methodology for the... You're muted. You've muted your microphone.
Sorry.
So I just wondered how much your model, your framework changed after the case study. Were you able to learn from the case study? How much?
We add some steps to guide the people in our company, and we offer also some tools tool to some guidelines to help them in to do some step.
Okay.
Like also some, for example, to analyze the need, some interview guide.
Okay. So they were definitely worth doing the case study to improve the model. Okay, thank you very much. Thank you.
Okay, thank you very much. It's about 5 to 2. I can't believe how quickly that's gone by. We've had so many questions that we don't really have time for a kind of general discussion at the end, but I think we've had a really nice discussion of each person's work. I've certainly really enjoyed finding out about what you are working on and hearing everyone else's inputs in the questions. So with that, I'm going to draw the session to a close. Thank you so much to all of our presenters for sharing your work, and thank you so much to the audience for asking so many questions, which always makes it way easier to chair these sessions, which is great. I hope you enjoy the rest of the conference. I think next up in the schedule is Jonathan Kagan's keynote in about 15 minutes, so perhaps I will see you all there. So thank you very much, everyone. Bye.
Bye-bye.
Thank you. Thank you.
Thank you.
Thanks a lot for chairing the session. And
No
nice
problem.
discussion.
My pleasure.
Oh, wonderful.
See you
Thank
soon.
you. Thank you. Thank you.